Division is to divide up in equal parts. So A divided by B is to, for example, if you have 6 apples and divide up among 3 persons, then how much do each person get? Yeah, in this case 2 apples. Or you can also say, for example, if you have 8 liters of water and you want to pour it in glasses containing half a liter each, how many glasses can you fill? Yeah, in this case it's 16 glasses. So these are some typical examples of division. You can also divide negative numbers. For example, if you have a debt of $10 and you divide the debt up for 4 persons, then each person will get a debt of $2.50. But this reasoning doesn't work, for example, if you have a division of the type 8 divided by -3. So what is that supposed to mean according to these 3 definitions or interpretations? In this case, you can use a more general definition of division. So this means what you should divide. So in this case, the definition of this is what should you multiply B with to get A. So what should multiply B with to get A? That's the definition of B that you can use, and it always works. For example, here, 8 divided by -3. That means what should you multiply -3 with to get 8? In this case, of course, you have to take 8/3 here. But also for the minus sign to work, you have to have a minus sign here. So in this case, this will equal to -8/3. So this is a general definition you can always use. This is a easier interpretation, but you can't always use them. Then what is 0 divided by some number not equal to 0, for example 2? Yeah, if you use the definition here that what is you should multiply 2 with to get 0, then you see that this must be 0. So this must be equal to 0. If you turn it around, you can have 2 divided by 0. What is that supposed to be? Yeah, then you should have a number that you shall multiply 0 with to get 2. But you see it is not possible to find any number here, so this is undefined. And if you have 0 divided by 0, then what should you multiply 0 with to get 0? So according to definition, this means what you should multiply 0 with to get 0. Here any number holds. So this could be any number, but in this case you also say that it's not defined because it could be any number. So also say this is undefined. Division is not commutative, so it doesn't hold in general that A divided by B is equal to B divided by A. Sometimes it can be, but not always. So this doesn't hold generally. For example, 1 divided by 2 is not the same as 2 divided by 1, of course. And also it's not associative. So you take A divided by B divided by C. It matters where you put the parentheses. So if you put it here, it's not generally the same as if you put it on the last 2 numbers. For example, if you take numbers 8, 4, and 2, if I first do it like this, then the first is 8 divided by 4 is 2, and divided by 2 I get 1. But if I instead place the parentheses here, then instead we have 8 divided by 4 divided by 2, that's 2. So this is 4. So we see it's not the same number depending on where you put the parentheses. So division is neither commutative nor is it associative. When you have multiplication, you have, for example, that minus times minus equals plus. and minus times plus equals minus, and so on. You have the same memory rules for division, and you can write it like this: minus a divided by minus b is equal to a divided by b. So for example, minus 4 divided by minus 2 is equal to 4 divided by 2, so it's equal to plus. And similarly, if you have minus a divided by b, it's the same as you have a divided by minus b, and both are equal to minus a divided by b. So you have minus plus, or plus minus, you get minus. So for example here, if you have minus 4 divided by 2 is equal to minus 2. Or you have minus 9 divided by 3. Or we take a plus up. If I have 9 divided by minus 3, then this is equal to minus 3. And this follows because we have the definition of the division that, for example, 9 divided by minus 3, that should equal the number. You should multiply minus 3. What should you multiply that with to get 9? And that has to be minus 3. So this is minus 3. So that these memory rules follows because the rules holds for multiplication. So it also goes over to the definitions of division. If you want to divide a sum of two numbers, a plus b, with the third number, c, then the rule says that you should divide both numbers with c. So for example, if you have 20 plus 15 and divide by 5, then you need to divide both numbers by 5. So you get 4 and 3, 7. This one should compare to, instead, if you have multiplication. If you have a times b divided by c, then only one of the numbers are divided. So either a or b, not both as in addition. So if we would have 20 times 15 divided by 5, then we should have 20 divided by 5 times 15. Or we should have 20 multiplied by 15 divided by 5. So in this case is 4 times 15, that's 60. And this 20 times 3, also 60. So this is a difference between addition and if you have multiplication. And the same rules holds if you divide a difference. If you have a minus b divided by c, then the same rule holds, but you get minus instead. And for multiplication, for example, if you have another rule, you will get, if you have a divided by b, you can write this as a times 1 over b. So dividing by b is the same as multiplying by 1 over b. So for example, if you have 6 divided by 2, that's the same thing as you have 6 multiplied by a half. So equal to 3. And this here is not a new rule, it's just a special case of the rule we already had, division of a product. Because I can write this as a divided by b. I can put in a 1 here, it doesn't change the number, it still is a up. And now I can use the rule for division of a product. So I divide 1, choose to divide 1, then I will get this. And that's just what we had above.